So, good morning, everyone, or evening, afternoon, wherever you are. As already announced, I will be talking about certain propositions on an internet for a burning world, and I hope everyone has a good mood. Let's see if we can change that. So, before we get into the topic, we first have to define a couple of, things about what I mean when I say certain things. And the first thing that is very integral to this whole set of propositions is the term burning world. And what I mean when I say burning world is exactly that. Our world is burning, like literally, especially in the northern parts of the Americas. We have huge forest fires. We had huge forest fires also in Southern Europe, countered by unprecedented rainfall over the last couple of weeks. And of course, also droughts. Here you have a comparison image of France in July 2021 and July 2022. And you just see that the land has dried. It's just dry. And I mean, it's something we kind of worked towards this. It's kind of our thing to make this world burn even further. I mean, it's uncombed industries, resource exhaustion, a couple of people having hobbies that burn in a couple of minutes what other people's set into the environment in terms of CO2 in a lifetime. We are waging wars against one another. We are destroying what we built over generations. And that's how we make our world burn. And before we now get into what this means for the internet, we also have to make very important comments about the thing of sides. So within this talk, I will, and you might have noticed, I'm a person of bold opinions, and I like to have bold opinions, and I will take sides. The thing is that in the end, everyone is necessarily the hero of their own life story, which means you might have a different perspective. You might see a different villain in a story. You might see a different hero, or maybe even an anti-hero. But I still argue that in the end, those often are very interchangeable. So even if we disagree on which side might be wrong or right, we flip them around, we should arrive at the same conclusion. And with that, without further expanding, let's get into the propositions. And the first part is the thing about care and centralization. My first proposition reads, operating systems requires operators to execute care towards their system, their users, and the infrastructure as a whole. And that is a very universal thing. It goes beyond digital infrastructure. It ranges from us having to apply care, and a picture I always have in my mind when I think about that is an old retired person gardening and taking care of roses. And infrastructure is a little bit like that. We do have to execute that care, and we do have to do things where we maybe never see the outcome of them if we want to properly operate infrastructure. There's this saying about planting dates, because a date tree apparently takes longer to grow than a lifetime to actually bear fruit. And we have the very same thing in, for example, infrastructure for the power grid, because there the planning horizon is often 40 to 60 years. Like, components will be in place for 40 to 60 years. So the engineers who are planning this, they will never see it being decommissioned. Often not only not in the job, but also not being alive. And that is already for the human mind to think about things that will have to endure beyond themselves. That's already difficult. But beyond this greater scheme of operating infrastructure, especially when it comes to digital infrastructure, we also need the smaller scale care. We need the care work, the emotional labor that comes with building something that is so ingrained in the way we as humans currently live. Think about it. What I explain to system administrators when I talk about this proposition is always, imagine you're sitting in your office, somebody walks in and says like, hey, do you maybe have a backup of my files, because my dissertation is due next week? And if you're a system administrator, you might have sat on one side of the table, but most people also have sat on the other side of the table. We all know in that situation, it's not really much about whether the backup is there or not. in any case, you will have to do a lot of maintaining that user's emotions because they currently have the feeling that they lost maybe 4 years of work at a very crucial stage and might just be totally lost. So the emotional part there is also very important and to be considered. And digital infrastructure encompasses all of that. Then, of course, we have the centralization. It's a very big topic. We have Google, we have Microsoft, we have Amazon, and that's basically the internet by now. And what we claim in our second proposition is that this centralization, this move towards these hypergiants, has actually been promoted by a lack of care for infrastructure. Because if we're honest, like the main driver of that, besides socioeconomic reasons, is also that it has become really, really difficult to operate independent digital infrastructure due to the complexity of systems, but also due to the prevalence of, for example, distributed denial of service attacks. At the moment, it's relatively easy still to generate enough traffic to take a small site, a small self-hosted project offline. And what you do to evade that is you go to Cloudflare, Akamai, Amazon, and they solve the issue for you. But the root cause of that is people actually enabling those DDoS attacks by running things on their networks, which do not really necessarily harm them specifically. That's something you can ignore, but they can be used to amplify network traffic for these large-scale denial of service attacks. If we're now starting with DDoS attacks, we are also, of course, touching IT security. And computer security, ransomware, all that, it's a very dominant topic in the news. And what we also claim is that there's actually a tension between privacy and security, which are pitting decentralization versus centralization. If you think about it, a university running its own mail server, how many people are responsible for that mail server? Maybe 1, 2? How big is the Gmail team over at Google? And how big is the security team for Gmail over at Google? It's just a matter of scale. And in addition to that, Google will always be in a better position due to effects we will also discuss later to follow certain security practices you can do well at scale. So as a user, you're in the situation of either, of course, choosing the more secure walled garden or going the self-hosting route, which might be more privacy preserving, which might be more distributed. But that in the end might mean that, well, either you have your emails spread over the internet because you made a mistake, because your setup was insecure, because you forgot something, or you have your emails with Google. So security versus privacy. Leading us to the next thing, which is that centralization and profit are inherently incompatible with care and care for infrastructures. And that is rooted in a very fundamental concept of the operation of large-scale systems. And it's a kettle approach. So in system administration, if you do something at large scale, and usually also in any other thing, even if it's like producing coffee over at McDonald's, you want to make things consistent wherever a user goes. And I mean, it's something about McDonald's coffee. Like, I think nobody here really likes McDonald's coffee, but everyone knows McDonald's coffee, it will always taste the same, no matter if it's in Berlin, Paris, or Islamabad. The McDonald's coffee will be not good, but the same. And you accomplish this by making things the same that are not necessarily the same. And that is this kettle approach. It's like herding cattle. While pets, like, or pets, I mean, I have 2 cats, which are getting like the most expensive cat food, that are getting treated really well, that are getting like more expensive doctor's appointment. You probably all also have like cats or know some people with cats who are a little bit too much into like making nice things for them. And if you contrast that to cattle, you have a lot of them. You can actually take care of them like really easily, like with just very few people, because you all treat them the same. And if one of them gets sick, you kill it. And if you want to apply that to digital infrastructure, you get the issue that, as I said, you have to make things the same that are not necessarily the same. And everyone who ever had to interact with Google or Microsoft user support and the most likely AI-driven tool, which does most of it, even if it claims to be a human, knows how that is. These systems work really well for 95, 99% of users. But if a decision has to be made to ignore a need of a minority for the sake of profit, well, that decision will be made. And we have seen that in the past. And I think the most critical example was the case of a startup that had produced implants to make people see again. Startup went bankrupt, has like a handful of users. And then there was a person walking down the stairs towards the tube, and it just went black because the servers were off. And you can see this in multiple other dimensions. Think about a child with special needs who has grown very accustomed to its talking puppet. I don't know, does Mattel currently have like a talking puppet on the market? But those are IT systems, so they will be discontinued eventually. And then for that single person, a world is burning down. But for the system at large, it's a necessity to remain scalable. And it also ties in with the time horizons we discussed earlier. Because if you have to make investments which will pay off in 40, 50, 60 years, this is really hard to argue if you will have to provide demonstrable shareholder profit within 5 years or 10 years. And I mean, 10 years, I think, are in economics already a really long time. So there you have this tension between like what it needs to run infrastructure, to carefully run infrastructure, and what technical and economic requirements make happen. And we have been going over hypergiants already, and this is a picture of a hypergiant. Well, actually, a real hypergiant, so a star, red giant star HR 5171. But also all real hypergiants like Amazon, Google. Who here had a MySpace account? Probably I'm just old. Anyway, the thing about hypergiants is they fail, they explode. And that can often happen far more quickly than one anticipates. So think about Amazon. We have already had this year the rise in cloud service fees. We had rising energy fees. It really depends on the margins you're having and how quickly you can run into a domino effect where a shrinking customer base, together with the infrastructure investments you had to make to provide a service at that scale, together lead to a domino effect of costs, killing even those huge companies we assume are just too big to fail. The question is, what do we do then? I mean, every single site you go to, even self-hosted tools are really hard to rid of it. They are including Google fonts from the Google CDN. What if that all of a sudden overnight is gone? What do we do then? Well, what do we do then is a really good question, especially if we are not only thinking in technical terms, but also in terms of what is to come. And we claim that when this world is properly burned down, and as we discussed, we are really working on that, communities caring for local and distributed infrastructure will be the future. It will not be the big internet. It will be a village, which of course will have some technology left over and some people taking care of it. But the focus will really be on keeping the systems that sustain a local community alive. And in that burning world of local distributed systems, functionality will be far more important than security, and still will be trumped by safety. So think about like a water purification system for a village in that post-apocalyptic world. It will be far more of a threat that the only person who has the access credential dies than it is to have everyone have those access credentials if security of that system is secured by a social contract. I mean, violate that trust and don't think the village will take kindly to it, and you will also run out of water yourself. However, if safety comes into the picture, for example, if a system would enable a takeover by an, or better terms, opposing village, well, then things will look different. But the first priority will be keeping things running so they keep people alive, which ties in with the complexity we're currently seeing. I mean, there's Docker, Kubernetes, all these layers upon layers upon layers. We basically have technology lasagna. And that's really hard to get a proper end-to-end understanding where you have people who really understand like the bit pushing protocol parts, the operating system kernel, the software stacks, the higher level protocols, up all until to the final interfaces presented to users. And in a world burning down, it will be very much about preserving knowledge and communicating knowledge. And the ability of people operating infrastructure to transfer the knowledge of how to keep that infrastructure operating to the next generation. And if that is getting too complex, there will be an issue. And we actually claim that the boundary of complexity, which is still sustainable, is that a single person, the worst case, can understand and repair the full system. But after the future, let's go back to the more, well, not so distant future, the path we are taking. And one thing to consider there is Internet Protocol version 6. So as a small introduction for those who are not necessarily far too deep in networking policy, originally in the 70s, we introduced the Internet Protocol version 4 that has 2 to the power of 32, so roughly 4 billion possible addresses, with roughly 80% of that being usable. If you look around yourself, you probably have more than one device. And even if every person on this planet only had one device, it's really hard to, well, get that addressed with less than half the addresses of that there are people. So in the 90s, we standardized Internet Protocol version 6, which is really nice, right? And we have more than enough addresses, 2 to the power of 128. Every single atom on this planet can get its own IP address. The problem is that the adoption of this new protocol is lagging behind, because especially in the US and in Europe, people just have enough IPv4 addresses. There's no urgent need to migrate. In the rest of the world, however, things are a little bit different. So the African region is currently being torn apart by investors interfering with how internet governance bottom-up traditionally worked, because they tried to extract IPv4 addresses from that region, because you can actually make a lot of money with them, right? A couple of months ago, the peak was around $57 per address. And if you think about like the minimum bunch of IP addresses you can trade, a network of /24, 256 addresses, and we're already talking around 15,000 euros. So it's interesting for people making not so ethical money, but it's also a burden for people who want to run small systems. So if you would want to set up an ISP, which is servicing like your local set of villages, or if you want to run a small self-hosted thing for a community, 15,000 euros are a really prohibitive amount of money to get an IPv4 block. At the same time, 15,000 euros for an IPv4 block, for Amazon, that's not really a thing, and they usually buy them in bigger blocks. So coming a little bit back to why these addresses are so rare, in the beginning of the internet, some organizations got really big chunks of the IP address pool. So Mercedes-Benz, for example, got a /8, and the /8 translates to 1/256th of all available addresses. MIT did the same. And what Amazon did, it went to MIT and was like, well, we could buy that. We do have the money. And Amazon solved its IP address problem for some time. But that is just further adding and adding and adding to the centralization of the internet. And if we would all just get our stuff together and adopt IPv6 throughout the bank, that whole discussion would be gone. And there would be no structural disadvantage anymore of regions that did not get enough addresses in the good old times when IP addresses were handed out by John Postal and scribbling them in his notebook, which is actually true. There's a little bit of reordering. So from 7, we're skipping to 10. And 10 is that systems should enable a better tomorrow and not burn the world even further. I mean, at the moment, Bitcoin miners are saving the Texas power grid by not needlessly burning energy. And what we as engineers should really be better at is deeply thinking about whether the thing we are building makes the world a better place. I mean, in the whole AI discussion, NVIDIA basically reintroduced Moore's principle into the whole supply chain of IT technology. All of a sudden, there's a reason again to basically replace everything every 2 years. That was kind of dead the last couple, 5, 10 years. And the question is, what are we using that for? So in these big corporations, you often have people just throwing AI at a wall and seeing what sticks. Burning energy, requiring this hardware to be manufactured, and also producing further e-waste. And that should really be a benchmark for us if we are building new systems. Do they make the world better? Which ties with a very difficult other issue of engineers. Engineers like to solve problems. And when we see problems, we are whipping out our technology bat or hammer. And then all problems have this naily look of something you can hammer in with technology. However, what we claim is that there are no technical solutions for social and societal problems. And we constantly try to do this. Politicians try to do this because they think like, well, innovation will solve it. Even small-scale nerd communities, which are like having issues like people are taking drinks from the fridge without paying for them, are usually pretty quick in implementing some really nice, fancy interface thing that does drinks accounting, which then usually just leads to a reiteration of the same problem, only that time involving computers. And the inherent reason is that you just can't solve social problems or societal problems with putting on some fancy technology hammer. If you digitize a shitty process, you will end up with a digitized shitty process. But for some reason, we are all stuck in this dream of technology solving everything. And I mean, COVID actually gave us one of the best examples. We spent millions and millions and millions and millions and millions of euros on really crappy technology to track whether people are vaccinated, where people have gone. And why did we do that? Because we couldn't solve the underlying societal issue, social contract of being honest when you fill out these documents, right? Have you been here? Or not forging the stamp in your nice little yellow book, which documents your vaccinations. I mean, we got rid of smallpox without computers, with those funny little paper booklets. And with all our technology, we made a huge mess out of what was around the past couple of years. And the issue was not the technology. It was that we had an underlying social issue, which we just ignored and hoped technology would make it go away. Bringing us to another thing people like to solve with technology, which is sanctions. And you probably all noticed Sputnik News has been sanctioned. There was also, after the invasion of Ukraine, internet people being like, hey, yeah, internet sanctions, we should do that. So they cobbled together in a couple of nights a proposal of how to do internet sanctions targeted against single IP addresses, which is somewhat interesting because the internet community has been talking to policymakers and telling them like, yeah, no, you know, like internet sanctions and targeted blocking, and no, that's technically not possible. Best we can do is some form of DNS blocking. We have been saying that for decades. And then something happens, and we make it happen within, like, basically an afternoon. Policymakers won't forget that. They will not forget that, and they will be coming back to us. And that will ultimately lead the internet to fall apart. Because if you think about internet censorship, and the canonical example is the Great Chinese Firewall, what these systems are a technical solution to ensure that the constituents of some policy domain are subjected only to digital content that conforms to that domain's policies. And if you start to implement some form of blocking to ensure that the European Freedom Internet does not let users access sites which are not GDPR compliant to protect them, consumer protection, and you try to order systems for that, and you end up with a product manager over at Juniper who has, or Huawei, or like, it's replaceable, right? Can also be Cisco, who is in charge of building censorship systems for whatever repressive regime you want to think of. They will look at that request and be like, oh, nice, same user story. Like, from the technical side, nothing to change. It's the same technology used for that. Only the purpose in the mind of the social construct community is different. But from the technology side, it's just a tool that ensures that certain packets matching certain characteristics do not freely flow. That's the technology part. And if you have that in place, you get into all these border conditions. So if you think about Germany, Germany is very particular about not liking gambling, like online gambling. And there's actually some prerogative to actually block gambling websites. If you talk to Malta, they are not that necessarily happy about online gambling sites being blocked. And that is only within the EU. Germany recently finally managed to get rid of that, I think it's from Third Reich Times, the ban on advertisement for abortions. Well, at the same time, I think in Texas, things are looking somewhat similar and even worse now. So what happens if those over there complain about, like, or doctor sites not being blocked because somebody wrote the site in English? What happens if they are like, well, you know, if you block our gambling websites, which are legitimate businesses, that's kind of like economic sanctions. And economic sanctions is, among friends, are not a nice thing. So you all of a sudden get into these subtleties, and then different policy regions will start to limit how the internet is looking in their specific domain. Another important thing to observe on the picture you currently see on the screen is how we are dragging the global south along. So the map shows the reachability of Sputnik News throughout the world, and you might notice that Africa has a lot of black dots. Well, the thing is, most traffic from Africa is actually flowing through Europe, mostly due to very old dependency relationships rooted in the colonial history of, well, the continent and the acts of the Europeans. So if you are in a part of Africa that used to be colonized by France, your traffic will most likely route through Orange. If you are in a Spanish colonized part, your traffic will route through Telefonica in Spain. It's things that have grown and where we are dragging people along even decades after they gained independence based on our perspective on the world, which leads us to the last proposition, very much ingrained with perspective, and that is that digital sovereignty is being used wrong. Because digital sovereignty is kind of the flying term of, hey, we want to be able to subject our constituents to the policies we deem necessary, and then only, you know, that internet traffic. It's kind of that thing, right? We want to have a digitally sovereign DNS in Europe, which means a DNS which follows European values. The problem with sovereignty is that it also means something different, and that is the ability to maintain and rebuild, and that's something we have completely forgotten. So with the progress in cloudification and the complexity, we had that in an earlier proposition, and also with the, it's hard to describe this more and more corporization and confidentiality of source code, so lack of open source, proprietary implementations. It gets really hard to rebuild systems. Who here has a Van Move bike? Might be an interesting question there, because that is a perfect example of that. And I mean, bikes, okay, if you would have told me 15 years ago that at some point in the future, people would be unable to ride their bikes because some IT company got bankrupt, I wouldn't have believed that. But it's still bikes, right? Like you probably can find somebody who is able to use, and this is a nice German word for a cutting device, flex, to get rid of certain locking parts of the bike, and you can ride it again. But this is actually perpetuating through all parts of our digital infrastructure. It's like pumps, heat pumps for like houses. Wind generation, solar panels, all these things have software in them, and of course also the basic network infrastructure. And what do we do when the vendor is going bankrupt and A, the cloud system disappears, or B, we can no longer replace parts in that because there's no documentation, there's no code, and we basically have to redevelop things from scratch. Well, at the moment we throw it away because we can buy something new. But what if there's no supply chain we can buy anything from? This whole perspective of digital sovereignty is completely overlooked because we all just hope and pray that the hypergiants will never blow. Question is, what do we do now? Well, the future won't be bright. And I don't know how old the average listener is in this audience, but I'm pretty sure all of us will see the really bad parts. But as engineers, it's always our job to make the future brighter. It's kind of a duty. Society let us become engineers, and in return, we have to give something back. And no matter who blows it up, who breaks it down, who's careless and tears the world apart, in the end, it will be a colleague, it will be an engineer who actually fixes what society relies on, or has to fix what society relies on. And it might be you. So, bluntly quoting Star Trek, it's the warriors who get the glory, it's the engineers who build societies. And in the end, it's only you who can take responsibility and make the world a better place. Thank you.